Hello, this is Dr. Mears. Today we are going to be doing an introduction to a system of linear equations. What you have in front of you is the same exact sheet that I have in front of me, and we're going to go through filling in the blanks and doing the examples, and then I'm going to have an ISN vocabulary definition sheet, and we're going to be using this sheet to help us fill that out. So we got a lot to do today. Let's get started. First, a system of equations is when we have two or more equations working together. So let's fill that out. When we have two or more equations working together. So we're working with just one, now we're going to be working with two. You could have 3, 4, 5, but we're just going to start with the two. All right, let's look to see what a solution is. The solution to the system is the ordered pair that makes both equations true at the same time. So let's fill those words in. It is the ordered pair that makes both equations true at the same time. Exploring the solution of a system of linear equations. There are three different types of solutions. The first type of solution that we're going to learn about is where they meet and they have one solution. The second type of solution is when they have no solution. And the third type of solution is when they have infinite solutions. So they can have one, none, or infinite solutions. So those are the three different types of solutions. So let's start learning about them. Please turn your page over and we see we have one solution. So the first type of solution is one solution, and this is the intersection of the two lines. Let's fill that in, the intersection. The coordinate where they meet. So we're going to see that two lines are coming together and they're going to meet, they're going to cross, they are going to intersect. So what does that look like? Finding the one solution. Write down the point where the two lines meet. So here we have two lines, and on your picture it's going to be a little bit more clear where they intersect than on mine. We have this first equation, which is y equals 2x plus 4, the equation of this line. Our second equation of the line is y equals negative 1/2 x plus 9. And so I actually gave you these two equations to see what they look like. So here's this line graphed, and here's this line graphed. So let's see where they intersect. So our solution, if we were going to write it in, would be the ordered pair, 2, comma, so I just counted over 2, then I'm going to count up 8. So our solution where they meet is 2, 8. And so what we're going to do next, we're going to actually check to see if this solution works. So we're going to actually check to see if it works in the first one and it works in the second one. What do I mean by that? Okay, well, this is checking the solution. What we have to do is substitute the coordinates into each equation to see if it works. So the first equation up here that I gave you is y equals 2x plus 4. So let's write that down. Y equals 2x plus 4. The second equation that I gave you was this one, y equals 1/2 x plus 9. So let's write that down. Y equals negative 1/2 x plus 9. What we need to do is put this point in. This is my x, this is my y, in for x and y and see if it works. So let's do it. So this is y, so matching up. So this is 8 equals 2. Remember, this is multiplication. We're putting the 2 in, plus 4. So all I did was replace my y with my 8 and replace my x with my 2. So what we're checking is to see if this side is going to be equal to 8. So that's why I have my little question mark there. I don't know if it's going to be. Let's do the math. 2 times 2 is 4. Bringing down my plus 4 equals 4 plus 4 is 8. And this side stays the same. I'm just carrying it down. So do we see that 8 equals 8? Yes, it works here, so I'm going to check it. Let's see if I can get a check mark for this side. Again, I'm doing the same thing. For y, I'm inserting that 8, and for x, I'm inserting the 2. Remembering this is multiplication. So I'm checking to see if I do this side, if it equals the 8 over here. So 8 equals negative 1/2 of 2 is negative 1 plus 9. 8 equals negative 1 plus 9 is 8. These two are the same number, and that's what we want, so it checks out in both. So this is what we mean by it working. It works because this side, which is 8, equals the math that we did over here, 8. Same here, 8 equals 8. If these two were different, it wouldn't work. It would not be correct. So what we did is first found where they crossed, wrote that point down, and then checked to make sure that it was correct. You may pause the video and go back over that if you wish. I'm going to go on, though, to the second type of solution, which is no solution. This is where the lines will not cross. They will be parallel. That's this word right here. And if we look at the slopes, which is m, if we look at the m, they should be exactly the same number. That's what should tell you. That's the hint. So let's see what that looks like. Finding no solution. Here's your picture. Notice this line and this line are parallel. They don't meet. It looks very different from the one that we had. This line here, I gave you the equation y equals 1/3 x plus 2. This line here, I gave you the equation y equals 1/3 x minus 3. Okay, let's move on. No solution. The two lines will never, ever meet. They are parallel. The lines both have a slope of, and let's look, 1/3 and 1/3. Remember, this is m. So they both have a slope of 1/3. And I said before, when they are parallel, they will have the same slope. So we checked to make sure that our answer was right in saying that there's no solution. And we verified that by saying that the slopes were the same, and that was the 1/3 for their slopes. Again, you can pause and review that. I'm going on to the third type. Flipping my paper over. The third type of solution. This is where you have infinite solutions. It says one line is on top of the other. There are an infinite amount of points that can be the solution. Let's look to see what that looks like. Here we have, if you notice, one line. I made double arrows here. I made a set of arrows here and a set of arrows here so that you could see that one line is on top of the other. The equation of this first line is y equals negative 6 over 2x plus 2. The equation of this little line is y equals negative 3x plus 2. So that's what it looks like when one line is on top of the other. So one line is on, for infinite solution, top of the other line. They have infinite solutions. And if we look here, what is 6 divided by 2? Could I simplify this a little bit more? Can I say negative 6 divided by 2 is negative 3x plus 2? I could, and if you notice, negative 3x plus 2, that simplifies 2, and down here it says negative y equals negative 3x plus 2. So they're the same exact equation. I just had to do one little step of simplifying that fraction. How do we check this? Well, it's obvious that one is on top, but let's say that we want to check. We're going to do the same thing that we did before in our first type where we had one solution, and that's substitute any coordinate on the lines into each equation to see if it works. So I have to choose a point. The point I choose on the line is, well, let's look. I like how this little point is here because that's the y-intercept for both of them. So the point is going to be 0, 2. Now I will check to see if it works. So I'll write down y equals negative 3x plus 2. Putting 2 in, negative 3 times 0 plus 2. So 2 equals, this is going to be 0 because I'm multiplying, plus 2. So does 2 equal 2? Yes, they are the same number. Now I could do it again for the other one, which is this, the negative 6 over 2x plus 2. But look, when we simplified it, remember it was the same one. So I really only had to do it once. However, let's just say that you really wanted to check to make sure. So writing down this original, 2 equals negative 6 over 2 times 0 plus 2. Any number times 0 will be 0, adding the 2. So 2 does equal 2 here. So even if I didn't realize to simplify and I did put my 0 in, I'm still going to have it work. So picking a point anywhere on those lines works, and that's how you verify it. So those are the 3 types of solutions. Now there's different ways to actually go about to solve solutions, and that's where we're going to go next. We'll be using 2 methods to solve equations that are in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. So can you please write that below slope-intercept, the words. The first way that we're going to be solving a system is solving by graphing. The second way that we're going to be solving is solving by substitution. I will have videos on both of those, and you will get practice sheets on both of those. After we learn about solving by graphing for slope-intercept and solving for graphing by, getting a solution by substitution, we are going to be learning about the standard form. So we're going to be learning about a new form, everyone, and it's going to be called standard form of an equation. We will use a third method to solve called elimination. I think that's one of my favorite ones. But we need it to be in standard form, so this will be coming up in a short while. We've really been working with y equals mx plus b a lot, and I feel like we need a little bit of a break, so we're going to go to standard form after that. That's the end of our video. That's the end of our little packet. I hope this helped. This has been an introduction to system of linear equations. I hope this helped. Talk to you soon.